First, we have to ask ourselves, what is a system of equations? Okay. Then once we figure that out, we're going to ask ourselves, how can I use graphing to help me find the solution to the system of equations or to solve it? And then the short video that follows this one is, how do I classify the solutions based on the types of solutions that I get? So a system of equations is a set of two or more equations with the same variables. It's kind of like piecewise, only these are not restricted on their x values at all. They'll go off forever. Both lines will go off forever in positive and negative infinity. We're going to focus on linear systems. There are lots of different kinds of systems. You could have linears with quadratics. You could have quadratics with quadratics. You could have quadratics with cubics. Lots of them, but we're going to focus on linear systems of equations. And then highlight this, because this is an important term, the solution of a system. When we look at linear systems, we're looking for an ordered pair that makes both equations true at the same spot or at the same value. Another way of looking at it graphically is it is the solution, is the intersection of the two lines. It's the ordered pair that makes both of them true at the same time, and it is graphically the intersection of the two lines. So when we're solving a system by graphing, we first have to graph the line of each equation. I've included the summary of techniques that we talked about in that remediation video that you watched last night. I've included those techniques on slide 9. You're going to find the solution by looking for the intersection of those lines. Sometimes you won't have an intersection, and that means there's no solutions. And sometimes you'll have every solution of one is also a solution to the second. Okay, so we'll talk about those in the next video. And then you want to check those coordinates. And then finally, in your daily assignment, you're going to be asked to classify. That is in that short video, classifying a system. Okay. So here we're going to graph the lines, find the intersection, the solution, and check it. All right, so let's start with this one. We've seen this equation before. I'm going to find my y-intercept. It's 0, -5. My slope is 1. It's -1 over. Let me do it this way just so that I don't skip any steps. It's 1, -1 over -1. It's the opposite of a over b, just like we learned before. And now I'm going to graph that. And you want to be as exact as you can. And it's going to be really hard for me on this screen. But you want to use graph paper and rulers. And I'm going to put this line together like that. Okay. And then this second line, x plus 2y equals -4. My x-intercept is -4, 0. When I plug in 0 for y, x has to equal -4. And my slope is equal to the opposite of a over b, so that equals -1/2. So here's -4, 0, and I'm going to go down 1 over 2. Down 1 over 2, and I'm going to keep going until my line intersects. There it is. Over 2. And I'm going to draw this. And here is my intersection. The x value is 2. The y value is -3. And now I'm going to check to see if it works in both equations. That's what I got visually. And so I do 2 minus -3. We want that to equal 5. And we get 2 plus 3 equals 5. 5 equals 5. And that's a check. In my second equation, I'm going to get 2 plus 2 times -3. We want that to equal -4. So I get 2 minus 6, and when I simplify that left-hand side, I get -4 equals -4, and so it checks. We'll classify these all in the next video. So save these notes. All right, let's try this system. We're going to graph y equals negative x plus 3. So let's see. I think I'll use the slope and the y-intercept. My y-intercept is 0, 3. That's here. And my slope is negative 1. So that's going to go like this. See, this is going to be hard for me. Here, and here, and here, and here, and here. So I'm going to try and connect all of them. If I were you, I would use a ruler and graph paper, okay, for your daily assignment. This one, I think I'm going to use, I might as well use the y-intercept. I have room. 0, negative 6. M is equal to 2. So I'm going to start here. And I'm going to go up 2 over 1. And up 2 over 1. And up 2 over 1. I think there's my spot right there. Up 2 over 1. And I'm going to connect. And here is my intersection. That's going to be at 3, 0. And I'm going to check just to make sure it works. So I'm going to plug in 0 for y. 0 equals negative 3 plus 3. So 0 equals 0. That's a check. And then 0 equals 2 times negative 3. Sorry, positive 3 minus 6. So that gives me 0 equals 6 minus 6. So that 0 equals 0. That's a check. We're going to classify in the next shorter video. Let's solve this one. I'm going to do x and y intercepts on both of these. Your choice. My x-intercept is going to be negative 2, 0. My y-intercept is going to be 0, positive 3. You know what? I'm going to graph this one in red. Okay, here. And here. And I'm going to connect them. And then this one I'm going to graph in purple. Should have been doing that all along. X-intercept is going to be negative 2, 0. And my y-intercept is going to be 0, 3. Oh, look at this. This is interesting. What do we have here? Okay, let's graph this. I'm going to graph it in purple. And I'm going to use like a dashed line just so that we can see how it overlaps. I'm going to use an X and an X. And then this is the exact same line. This is one where every solution in first equation is a solution in second equation. We call this infinite. But when we use infinite, it's in that the same ordered pairs of equation 1 also solve equation 2. And we don't really need to check it because we can see that the lines just kind of overlap. They both have the same x and y intercepts. Okay. All right. This one, we're going to graph the line y is equal to 2.5x. So my y-intercept is 0, 0. and my slope is 2.5 over 1. You could also go up 5 over 2. Okay. On this problem here, what we want to do is we want to get it in, I chose to get it in slope-intercept form. And so my y-intercept is 0, -5, and my slope is the same thing as 2.5 over 1, or up 5 over 2. That would also get you there. And so my first line, this should have been all in purple. I'm in red, so I'm going to do this one right here in red. And here we go. And I'm going to go up 2.5 over 1, and up 2.5 over 1, and down 2.5 over 1, and down 2.5 over 1. Oh, and I'm going to connect them. And then this one I'm going to do in purple. And I'm going to start at 0, -5. That's down here. And I'm going to go up 2.5 over 1. And let's see how the slope is the same. These things are never going to touch. So what kind of lines do we have? They're the same slope, different y-intercepts. So these lines are going to be parallel. So these are parallel lines. I know that because they have the same slope, different y-intercepts. And so they never intersect. So there are no solutions. So we don't really have to check this one either because we see that they never cross. Okay. All right, you're going to have a worksheet that you're going to do. Make sure you watch this second little video on classifying systems. Thank you for watching.